and welcome, and in this video we're going to be talking about graphing absolute value functions. Now this is a continuation from our transformations kind of series with absolute value functions. So in the last video we have talked about our parent function of absolute values, a transform function. We also talked about all the different types of transformations that can be brought upon an absolute value function. And in this video, we're going to actually apply all of this and graph absolute value functions by hand. So if you haven't watched that video, make sure that you do. But let's go ahead and jump into a graphing problem, okay? So I'm going to be graphing these functions using our transformations. And we're talking about transformations, we're always talking about the parent function or comparing our function to the parent function. So as I'm looking at the parent function, which I have graphed right here below, I am looking and noticing that there are two differences with our function. We are subtracting 3 inside and we are subtracting 2 outside. Since there are two differences, that is telling me that there are two transformations for this function. The minus 3 inside is shifting us to the right 3 units. And the minus 2 outside is shifting us down 2 units. So I'm going to go ahead and write those down. And now notice I wrote them in a specific order. When we are applying transformations, we are always applying them in direct order from left to right. So we are going to first shift to the right 3, and then we are going to shift down 2. And it is very important that we follow this order. More specifically, because if we apply any sort of shifts before a vertical stretch or compression or reflection or anything like that, our graph is going to be super wrong. So I always apply the transformations in order from left to right, just like you read a book. I find that is the kind of easiest way to convey that message. So we are always going to apply transformations from left to right. Now I'm just going to go ahead and actually shift these points, but when you move on to higher level mathematics, especially once you start getting into like pre-calculus and stuff like that, you are sometimes going to have to transform a table of values. So I'm also going to talk about how we would perform arithmetic on a table of values and basically these particular points and apply these transformations doing that. So if I'm shifting to the right 3, that is affecting only the x coordinates because a shift right is a shift horizontally and our horizontal coordinate is x. So if I'm shifting 3 units to the right, that would be done by adding 3 to the x coordinates or the x values. So that's how we would shift to the right 3. So basically I would take every single point and add 3 to the x values. So 0, 0 becomes 3, 0. 1, 1 becomes 4, 1. 2, 2 becomes 5, 2. And so on, because I'm adding 3 to all of the x values. Negative 1, 1 becomes 2, 1 because I added 3 to the x value, and so on and so on. And I'm not going to do it for every single point. I'm just going to get a couple on each side of the vertex, okay? So that would be a shifting to the right 3. The next transformation is shifting down 2 units. And if I'm shifting down, that is a vertical shift, which is going to affect our vertical coordinate of y, because y is the vertical coordinate. So to shift down to, I would be subtracting 2 to the y values. So I'm not transforming the parent function anymore. I'm doing it on the points that we just made because this is shifting to the right 3. So now I'm going to shift each of these down to by subtracting 2 from all of the y coordinates. So 3, 0 now becomes 3, negative 2. 4, 1 becomes 4, negative 1 because I subtracted 2 from y. 5, 2 becomes 5, 0 because I subtracted 2 from y. And so on and so on. And now we are done with our transformations. There's no more transformations taking place. So what I would do is I would now connect these points and make our absolute value function. What I'm going to do first is I'm going to first subtract the points in that light blue. That was just when we shifted to the right 3, but we needed to transform it a little bit more. So I'm going to go ahead and get rid of those points first. And there would end up being my graph. As we can see, every single point has been shifted to the right 3 and down 2. Our vertex used to be 0, 0. Now our vertex is 3, negative 2. So that is how we can shift, apply vertical and horizontal shifts to a graph. Those ones aren't too bad. If I was shifting left instead of right, I'd just be subtracting from the x values. If I was shifting up instead of down, I'd be adding to the y values. Now, the next transformations I want to talk about is our vertical stretches and compressions, as well as the reflection over the x-axis. So let's take a look at one of those examples. So we have a new example here, and in this problem, I do see 3 transformations now, because I see a 2 multiplying outside, I see a 1 adding inside, and I see a 3 adding outside. So those are going to be 3 transformations. Now the first of which, we always apply from left to right, so I'm going to list them in order from left to right. This 2 multiplying out in front is telling me that it is vertically stretching it by 2. So we have a vertical stretch by 2. The plus 1 inside is telling me that we are moving to the left 1. And the plus 3 outside is telling me that we are moving up 3. So those are 3 transformations, so let's write those down. So those are 3 transformations. Now I need to apply the vertical stretch first. The vertical stretch is going to be done by multiplying all the y values by 2. That is how we apply a vertical stretch and a vertical compression. So let's say this was vertically compressed by 1/2. I would just multiply all the y values by 1/2. So essentially, whenever you have a number multiplying out in front of the absolute value, the way we apply that transformation, graphically speaking, is we multiply the y values by whatever number that is. So I'm going to multiply the y values by 2. So the way that this is going to look is 0, 0 just stays 0, 0, nothing changes there. But 1, 1 is going to become 1, 2, and negative 1, 1 is also going to become negative 1, 2. 2, 2 is going to become 2, 4. 3, 3 is going to become 3, 6, and so on and so on and so on. And that is because we multiplied all the y coordinates, the y values of each coordinate, by 2. So that would be our vertical stretch by 2. Now the next 2 transformations are going to be very similar to the last problem. We are shifting 1 left, which means I'm going to subtract 1 from all the x values, and we are shifting up 3, so I'm adding 3 to all the y values. And it's very important that we apply the vertical stretch before shifting it 3 vertically, because we would mess up our points if we didn't follow that order. So let's go ahead and do that. So the purple is now after the vertical stretch by 2 and shifting left 1. So let's go ahead and finish this off by shifting 3 up. I'm going to get rid of the blue points now since we've already covered those. And that is our graph. As you can see, the shift 1 left and shift 3 up is where my new vertex is. It is at -1, +3. So the shifts, horizontal and vertical shifts, tell me basically exactly where my vertex is going to end up. The vertical stretch did not affect that, but what the vertical stretch did is affect how steep these points basically are, how steep the overall graph is. Since it's being vertically stretched by 2, you can see it is not nearly as wide as our parent function in black. So that is how we apply a vertical stretch. I want to cover just one more problem, and this will have a reflection over the x-axis in it. I want to show you guys how we can do that. So we have a new function here, and I see 3 differences. Some of you might only see 2 differences, but I actually see 3 differences because there are 3 different transformations happening here. The first difference I see is I see a negative out in front of the absolute value function. That is its own transformation. I also see a 3 multiplying, technically a -3, but the negative really only tells me one thing. That negative is telling me that it's being reflected over the x-axis. That is its own transformation. So we are reflected over the x-axis first. So I'm going to go ahead and write that down. Now the next transformation, I see that -3 multiplying, but the negative really only tells me the reflection. I see a 3 multiplying as well. What that's telling me is it's being vertically stretched by 3. And the last thing I see is the -4 inside, which tells me we are being shifted to the right 4. So those are our 3 transformations. So if we were applying each of these in their kind of own order, the first thing that would happen is that we would be reflected over the x-axis. And the way we do that is by multiplying the y values by -1. Then we would be vertically stretched by 3, which would be multiplying the y values by 3. However, when you are being reflected over the x-axis and also have a vertical stretch or compression, you can actually kind of combine these two and do them at the exact same time. Basically, what I can do is I can multiply the y values by -3. Now, although we can kind of combine these transformations into one big step, you still need to list them as two separate transformations. And it's very, very important that you always have the reflection over the x-axis as its own separate transformation and never attach that to the vertical stretch. We would not say this is vertically stretched by -3. It can only be vertically stretched or compressed by a positive number. The negative only tells us it's being reflected over the x-axis. And I know I'm getting really repetitive here, but it's because every year, many people will tell me, hey, this is being vertically stretched by -3, when that is not completely true. That's not completely true. That's not at all true. Okay, so make sure that we are listing those as two separate transformations, but we can apply them in one big step. So I'm going to go ahead and now multiply all the y values by -3, so you will see the reflection over the x-axis as well as being vertically stretched by 3 all at the same time. So that would be the reflection over the x-axis as well as the vertical stretch by 3. I can see that, one, it's opening upside down, which is telling me it's reflected, so I can see that there. And I can also see that it is much more narrow than it originally was, so that is the vertical stretch in action. The last thing that I need to do is I need to shift to the right 4, and to do that, all I got to do, once again, is add 4 to the x values. And that would be our final graph. As I can see, it is opening upside down. That's a reflection over the x-axis. It's much more narrow. That is a vertical stretch by 3, and I am shifted to the right 4. So those would be all the transformations in action. I hope this video was helpful. If you have any questions, please feel free to let me know. Make sure you're practicing transformations, because we apply these transformations in the exact same way for every single function we will cover over the course of the entire year. So make sure that you are recognizing and practicing recognizing these transformations and applying them. And as always, if you have any questions, make sure you let me know, and I look forward to seeing you guys in the next video.